In this video, I'm going to be talking about the most common mistakes made with analyzing motion graphs or kinematic curves, and a strategy of how to properly approach these graphs in order to correctly identify what type of motion is going on. One of the first things that is a common mistake is taking a look at the shape of one graph and applying that same approach to a second graph. For example, if you have a position versus time graph that is a perfectly flat line, that means the object is not in motion because the position is staying exactly the same as time is elapsing, therefore it's not moving. Now, if you see that same sort of line on a velocity versus time graph, your brain might automatically tell you that you're looking at something that's at rest. But now you're looking at a velocity versus time graph, so that just means the velocity is constant. And if that velocity is constant and it's anything but zero, then it's definitely moving. That means it's in motion. So that's one of the first mistakes that is commonly made. One of the others is taking a look at a graph and reading it too literally. For example, if you take a look at a graph on a velocity versus time graph and it's doing something like that, or if you take a look at a position versus time graph and it's doing something like that, just because you see the line literally going down, it might make you think that the object is slowing down because something in your brain is telling you see negative slopes and you see the line going down, but that doesn't necessarily mean it is slowing down. In this case, it's actually speeding up because your number is starting at zero and it's becoming a progressively larger negative number. That means it's going faster and faster in the negative direction. That's actually the same case in this graph for the position versus time graph. As the slope is getting steeper, it is moving more quickly in the negative direction. So that's common mistake number two, is reading a graph too literally and then improperly analyzing it and thinking something is slowing down just because a line is going down. Now, the very last mistake is maybe just not knowing enough detail in order to properly analyze a graph. For example, if you see a graph such as this one, where you have a constant negative acceleration, in a lot of cases you might be thinking negative acceleration is slowing down, which is definitely not the case. So in a lot of cases that might be true, but a negative acceleration could actually mean speeding up or slowing down. For example, if this line is at -2, that's -2 meters per second squared, which means that you're subtracting 2 meters per second every second. Now, if something is going a positive velocity, say for example, positive 10 meters per second, and you're subtracting 2 meters per second every second, that makes 10 meters per second go to 8, to 6, to 4, to 2, and then to 0. So that is slowing down. But what if something is already going in the negative direction? So what if it's going at -10 meters per second, and then you subtract 2, then it becomes -12, -14, -16, and so on, which means that it's actually going faster and faster in the negative direction. So there's not exactly one clear-cut strategy in how to approach this, but this is what I would highly recommend as my strategy in approaching all these different types of graphs. The first thing you do is take a good look at what kind of graph you're looking at. So when you're doing physics and you're analyzing a bunch of motion graphs, you might be looking at a position versus time graph, velocity versus time graph, acceleration versus time graph, and go back and forth between the different graphs. So the first thing to do is not read the graph too quickly. Take a moment to take a look at what's on each of the axes. All right, so after taking a look at step number one, you want to make sure you stop for a second, take a look at what's on your axes. Are you taking a look at position in time, velocity in time, or acceleration in time? And then number two is, after analyzing the line, kind of tell yourself a little story of what's going on. So as the time is elapsing, basically create a sentence or scenario that describes what's happening to the position, velocity, or acceleration as the time is moving on. Okay, for example, if you're taking a look at this velocity versus time graph right here, if you're taking a look at it, and you always go from left to right because the time always starts over here, and you notice that the line is becoming progressively more negative. So the slope is constant, but that negative number is getting larger and larger. And you can even make up a number if you don't have any. So say it goes from -2 to -4 to -6. Okay. So then if you create a story or a sentence to describe what's happening to the line, you will more accurately come up with a better description of what's happening with that object. So this one, we're going from -2 to -4 to -6. Okay, is that slowing down? Well, it's not slowing down because that negative velocity is getting larger. It's not moving at a constant velocity, although it has a constant slope, because that number is clearly changing. So if you take a moment to stop, take a look at some of the values, or even create some of your own values just to help clarify some of your thinking, that will definitely help in analyzing the graph properly. And number three, which pretty much applies to almost every area in physics, you just want to make sure you really develop your background information of what's going on, really understand the concepts and what's going on. What are you looking for? Are you looking for data points? Are you looking for slopes? What is it that you're looking for? So if I'm taking a look, say, for example, at this first line over here, we might be looking at how fast it's going. The slope starts fairly flat, so we're going to say that's maybe about 0. It's not moving to begin with. And then we have a progressively steeper negative slope. So the jump in its position within a period of time is changing, and as the slope gets steeper, that means it's moving a little bit more quickly. So if you didn't know that the slope of a position versus time graph was the velocity, that would be a little bit hard to analyze. So number three is definitely having a good base and definitely know your content knowledge pretty well before analyzing the graphs. All right, so let's go ahead and recap our steps, and then I'll go ahead and show you how I can apply them. So let's say, for example, we had a position versus time graph that looks like this, or a velocity versus time graph that looks like this, or an acceleration versus time graph that looks like that. Let's go ahead and apply these three steps and make sure we properly analyze these three kinematic curves or motion graphs. So I'm taking a look at my first curve. I want to be careful not to say that it's speeding up, even though I see my line going up. So let me just stop and take a look at what's on my axes. This is just showing me my position. So I just know that I'm moving forward, and as I'm taking a look at it, it's curved. So I'm not moving forward at the same rate because the slope is changing. So two, I'm going to create an explanation or maybe look at some numbers. And I see that my numbers are jumping in position fairly quickly in the beginning, and that number is starting to steady out towards the end. So if I start to write a sentence or say some sort of explanation in my head, and I'm describing how the position is jumping a lot in the beginning and not so much at the end, I might start getting the idea that it's something slowing down. And number three, definitely knowing your concepts. If you know that the slope is the velocity and that slope is becoming less and less steep, so we have a very steep positive slope right here, and it's starting to flatten out, then we would know that our velocity is getting progressively smaller, and those slopes are all positive. So it is an object moving in the positive direction, slowing down. Now let's take a look at our second one. Our second one is this green line with a negative slope. So I'm going to stop. What's on my axes? I'm taking a look at velocity. So I have a velocity that's starting as a large positive number, and it's getting smaller and smaller and smaller and moving towards 0. So I stopped, looked at my axes, kind of created an explanation. I'm kind of looking at my numbers and seeing how they're starting high and then starting to drop towards 0. That would probably give you the sense that it's something that's slowing down, which it is. So we have something that is moving forward because it's all above 0. So that means that it's a positive velocity, but it is decreasing, so it's slowing down. So I definitely want to make sure I know my concepts. and I'm aware that everything above the x-axis is moving in the positive direction. But because it's moving towards 0, that means my number is decreasing and heading towards a stop. So I made sure I was looking at my velocities. I create an explanation of what's going on with them. I kind of get a sense that it's slowing down, and then I knew that it's something that's going positive and slowing down because it's above the x-axis, but it's heading towards 0. And then for my last one, I have a flat green line above 0. So I have a positive acceleration that's constant. I don't want to be too quick to say that it's just a constant velocity or something that's not moving. So I'm going to stop, take a look at what's on my axes. I do have an acceleration, and acceleration is the rate that velocity is changing. So I know that my velocity is changing for sure, which means that it's moving, and the way that it's moving is changing every second. So create an explanation. Now this sort of depends on the scenario. This doesn't give me a whole lot of information whether it's speeding up or slowing down. So you definitely want to know your concepts and what you're looking at. So typically you want to take a look at the slope of your velocity versus time graph to create your acceleration versus time graph. For example, this green slope and this red slope are going to be represented by this purple slope over here. Sorry, this purple line that's flat. That doesn't really have a slope because these have a constant negative slope. So that's showing it has a constant negative rate of change. So all I know for this one is that it has some sort of positive change in the velocity, which means that it is a positive velocity that is getting greater and greater, or it's a negative velocity that is getting smaller and smaller. So that doesn't give me a whole lot of information, but I made sure I took a look at what's on the axes. I create an explanation depending on how much you know. That can kind of vary of how much of an explanation you can create. And then definitely know your concepts. Like I said, the big concept is positive acceleration isn't always speeding up. It is speeding up if something is already going in the positive direction, and it's slowing down if something is going in the negative direction. So I hope that was helpful in helping you identify some common mistakes that people make and a strategy in which to apply to properly read these kinematic curves. If you need more information, then click on the card above. There's a video called Kinematics Curves 2 that breaks down all these graphs in a ton of detail with every different variation. So definitely take a look at that link if you need a little bit more help or more detail. Thank you for watching and listening.